in this module, I want to talk about viruses and worms. This is another a la carte subject matter here, very similar to Trojans, but different because the context has changed to viruses and worms. So let's go ahead and get started, okay? So a couple major components here. We've got the basic concepts we'll cover, the different stages of a virus, why did people even do this in the first place, the different tools in which we can use, the different types. We'll talk a little bit about malware analysis, and then the distribution techniques, and then we'll wrap up with some of the countermeasures that are probably most common used in the industries. So let's start talking about some of the major concepts first. Well, ultimately, a virus and worm is going to change the integrity of your target, right? So you basically have the alteration of some sort of data. Remember that this software has to get to the system. Now, from a virus point of view, a human has to basically click the virus or start the virus, where a worm can replicate on its own. It does not need a human involved. Ultimately, that's going to lead to some sort of corruption of data or files or system resources. And so that's really the big picture. Also, the different propagation techniques, you know, as a virus writer or worm writer, how am I going to get this thing out to the internet or to my targets so that ultimately I can get an infection? Ultimately, I want to get it out there and get an infection, but I also don't want to be detected right away. So I have to come up with some sort of mechanism to actually, how am I going to hide this? And this is where viruses like multipartite or terminate and stay resident or polymorphic, these types of hiding techniques or stealth or tunneling techniques come into play. Also, same thing with mutation, right? This goes more into how is the defensive person going to detect my virus or worm. Is it a signature-based system or an anomaly-based system? And every time that they try to detect, can I mutate and come up with some other version of this software so that ultimately I can keep my infection out there the longest possible way. Also, integrity. Now remember, in the early parts of penetration testing, everything that we did was focused on disclosure. But now that we're into the big picture of system hacking or Trojans and viruses and worms, these are realistically the principle of integrity in play, because we are changing our targets and our networks and the corporations, okay? So let's back up and let's look at the different stages in which a virus or a worm goes through. All right, somebody's got to design the virus, and this is where you, the penetration tester or the hacker or the white hat or the black hat or the gray hat, come into play. You have to design it. Most of the time, you could write the code yourself, you know, in the very, very manual way. But if you wanted to take the script kiddie way, you could use one of the virus or construction kits, virus worm construction kits that are out there. And we'll talk about those in a minute. So you got to design the virus, then you actually have to get it out there. So what are the replication techniques? Ultimately, once it's out there, some user or computer is going to have to get infected, so there's got to be a launching mechanism. With a virus, the user launches it. With a worm, the system can get infected without the user even being involved. Then ultimately, we're going to need a way to detect this and then ultimately remove it. All right, but let's back up here for a second and talk about launching it. Some techniques, like fragmentation techniques, are very, very popular in terms of how do you actually get this piece of code to launch. So you can move executable code around, you can rewrite headers, and things like that in terms of fragmentation, and that can aid in your increasing the likelihood of actually getting the virus to launch. Detecting. Well, how is somebody going to detect the virus or the worm, okay? So you could naturally scan for it with some sort of host-based or network-based antivirus software. You could use an integrity platform like Tripwire or some sort of integrity monitoring or hashing program to basically compare what's been changed on that system, or intercepted at some sort of gateway relay point like a mail server or a strategic network location, or actually on your end hosts as well. And then ultimately remove it which is most of the time what the system administrators have to deal with, right? So they go up, hey, detected with a virus or worm, let's go ahead and fix it. So most system admins pick up here, but most penetration testers, they do all of the pre-work, the designing, the replication, the launching, and trying to avoid detection for as long as possible. So the cool part about viruses, Trojans, and worms is like you actually get to think like a criminal. All right. In an ethical situation, when you're a paid penetration tester, you have a permission slip to basically accomplish some result for an organization proactively and help an organization go through these scenarios and then help them develop the countermeasures so that it actually doesn't happen in a live real-world circumstance. Okay? So let's talk a little bit about why. Why even do this? Right? Why should the hacker or the penetration tester even do this, right? So I guess more from a malicious point of view, well, perhaps there's some sort of financial gain, all right? Maybe it's simply to play a prank. Maybe it's more terrorism or destruction oriented, where you're actually trying to accomplish some sort of malicious objective. It could be like an I hate you messages that you want to send. Maybe it's a political campaign. Nonetheless, it's something that typically changes the availability of your target. In other words, knocks them offline or something to that effect. Okay? Let's talk about the different types of viruses and worms, okay? There's boot sector viruses that infect the boot sector. There's file or multi-party, which not only infect the boot sector, but also infect the partition tables and things like that. There's your old classic macro virus. You have the ones in red here are actually kind of more modern techniques, where macro is kind of a little traditional. It's been around for probably decades now, but the new latest and greatest are like tunneling concepts, tunneling through ICMP or tunneling through HTTP or tunneling in general. Or sparse. There's a type of virus called a sparse infector virus, which would wake up, let's say, on the 15th of every month and then pop up for a while, infect a bunch of systems, and then hide itself. And so really what that does for the network administrator makes them run around like a dog chasing their tail. They think they've got everything fixed, and then the next month comes around and boom, it's back again. So it's literally this get the network administrator to chase their own tail. Polymorphic. Great technique because how do you eat an elephant, right? One bite at a time. Poly, many, morphic changes. So this virus or worm goes through many changes or many iterations of its code, ultimately to avoid detection. The same thing with metamorphic. While polymorphic changes its signature, generally metamorphic is identified by changing the characters which are used. So it might go from like a lowercase a to an uppercase a or to an out sign. And it's kind of an older technique. Shell infecting viruses, cavity viruses which erode or eat away at files or file systems, or one of my favorites, terminate and stay resident. It's my favorite because realistically the system administrator thinks that the software is gone, but it's still in memory, and then you can use other applications to trigger a relaunching of the program. So unless the system administrator reboots all of their system and flushes out their memory, it can pop back up and hey, surprise, we're now infected again. So that's one of my favorite ones. Let's talk about distribution. Well, there's different ways in which you have to get your software infected or your virus or your worm infected on your targets. So part of this is just good search engine optimization, right? If you can get a highly ranked web page and, think of it this way. Would you rather be on the first page of a major search engine or page 100, right? If you can get your virus or link or something like that at a higher ranking, you increase the likelihood of your infection. So SEO and clickjacking, realistically, in my opinion, work very, very, very closely together. Clickjacking is just taking over HTML code or the links or the clicks that we click on and actually takes you to some sort of malicious source where you'll get a pop-up or be forced to download some sort of code. Or maybe it's a phishing or spear phishing or a whaling style email in which your target now clicks on a link in an email and then is forced to install some code or a worm. Or maybe it's through traditional malicious software or malware. Or maybe it's a legitimate website that has been taken over by a hacker or an attacker. This is a lot more common than you think. For example, it may just seem like a run-of-the-mill website, but if a hacker or an attacker found a backdoor and they upload their phishing scam to that, well, they might not be changing the integrity for you, the end user of that website, or realistically caring about hacking your database or really knocking you offline. They're just using you as a host to host their phishing scam so that they can go attack the world and lure everybody else. So they're just using your resources. So you got to watch websites. Also, drive-by. One of the classic examples of drive-by infections is free Wi-Fi. People are walking in New York City, for example, and they see, oh, here's a hotspot, it's free Wi-Fi. They click on that, it runs a little piece of code, and it changes their device to now being a free access point. So in theory, everybody that walks by or drives by that specific access point turns their access point into free Wi-Fi, which then infects, and then infects, and then infects, and before you know it, the whole world is now connected with free Wi-Fi. All right? Let's move on to malware analysis. We're going to need some sort of analysis environment. So the concept really comes from farming. Have you ever heard of a sheep dip? If I ask you that, you'd probably say, no, I've never heard of a sheep dip machine. Well, think about a farm, or if you ever had a pet, you probably have given them a flea and tick bath. Well, what that flea and tick bath was a way to remove the bugs. All right? So if you can insert your code into some sort of virtual machine or virtual environment or isolated environment, and then allow that code to infect the virtual or isolated environment, well, then you can run all of your port scanners, your registry detection tools, all of your analysis tools that you possibly have, and then basically see how those infections take place. And we'll talk a little bit more about that when we look at some of the tools. Okay? Also, some sort of sensor on the network, either on the desktop or on the server or on the network. You need some way to detect a virus or worm. And I typically chalk that up to just like antivirus software, at least for now. But the latest and greatest way to do this is basically through virtual machine software, although you realistically could have a dedicated machine that's isolated, not plugged into the network. It's just nowadays, it's really realistically easy to accomplish that through virtual machines. Let's go on to indicators. Well, if you want to know the indicators of any virus or worm, use a tool. Use these construction kits, because you can literally point and click and see things like, change your right and left click of your mouse buttons, open and close your CD-ROM drawer, display funny text on the screen, flip your monitor, right? So if you want to learn